This video is about a process called synthetic polynomial division. Since this whole video is going to be about dividing polynomials, I thought a good place to start would be, why do we want to divide polynomials? There are really many answers to this question. It helps us factor is one of them. The one I'm going to give you right now, though, is that we already know how to add, subtract, and multiply polynomials. The only basic operation that we're missing is the division of polynomials. If you'd like to pause this slide here and go through these examples, you'll see that you actually knew how to do addition, subtraction, multiplication already. Multiplication is really just foiling. So let's now see how we would divide polynomials. I'm going to start with an example of just regular division. No x's, no exponents, so we're just doing regular division. Up at the top, you can see three different ways to represent the same division problem. They all say 149 divided by 6. The red number, which is the number that's being divided, is called the dividend. The green number, which is what's actually being divided into the dividend, is called the divisor. So in this case, we have 6 as the divisor and 149 as the dividend. These words will carry over into polynomial long division as well. The answer we get will be called the quotient. So the answer to a division problem is the quotient. So let's just look at how we would actually do this problem. So I've set up at the bottom 6 divided into 149, so it's 149 divided by 6. So the first question to ask ourselves is, how many times does 6 go into 14? Well, 6 times 1 is 6. 6 times 2 is 12, so we can still go more. 6 times 3, though, is too big. So it only goes in 2 times. So we put the 2 at the top, and then I'm going to do short division here. So I'm going to put the remainder, which is 2, right there. This is kind of a shortcut. So instead of long division, it's more a short division process. So how I got the 2 was that 2 times 6 is 12, and 14 minus 12 is 2. So we're left over 2. Now the next question is, how many times does 6 go into 29? Well, I think the biggest one would be 4, because 6 times 4 is 24, and then we have a remainder still of 5. So in old days, I think you used to add some zeros and keep going. But here, let's just say that our quotient is 24 with a remainder of 5. So that R5 means our remainder, what's left over, and this is called the quotient, as I mentioned. Now, how are we going to do this with polynomials? There is a long process called polynomial long division that will always work, but it takes a long time, and there are so many little places to make mistakes. So I'm going to show you something called synthetic division. Now, synthetic division is kind of magical. It's almost like, I don't know how it works. But so I'm just going to walk you through the steps. Try not to think why, just try to follow the steps that I do. So the first thing to do is to label my parts. So this one's going to be the dividend, and this polynomial is going to be my divisor. Notice they are both polynomials. So the first thing to do is look at the divisor and notice the number that's with the x. So we have x minus 3. So I'm right now focusing on that minus 3. I'm going to grab that minus 3 and change the sign. So minus 3 with a change sign just becomes a positive 3. Then I put it in its own little box over here on the left. Okay. Now the next part will be to look at the dividend. Oops, I spelled that wrong. No, I didn't. Dividend? Yeah, dividend. And again, I'm going to focus on the numbers, not the x's. So I'm just going to copy down my coefficients. So I got the 2 from there, negative 3 from there, and 4 from right there. All right. Then I draw this line, make sure you leave this gap here. So first thing to do is I am going to bring down this 2. Then I'm going to multiply 3 and 2, and I'm going to put my answer right here. So my answer will be 6. Now I add these two numbers. So negative 3 plus 6 is a positive 3. And then I repeat the process. So I go back to my positive 3 from the divisor, and I multiply it now with 3, and I put my answer now below this 4. So 3 times 3 is 9, and then I add these two, so I get a 13. Now I'm going to put a bubble around this, and you'll see why in a moment. So this is great. We have some random numbers, but how does this actually give us the answer to a division problem? Well, these, if you remember at the beginning, we took away the variables and we just grabbed the coefficients. So now we need to put the variables back in. So I'm going to recopy so that we have a little more space. 2, 3, and 13. So how are the variables going to go back in? Well, I know they're going to get an x, because that's what I took away. And this is a positive, so it's going to be x plus. Now, the question is, though, what should these exponents be? What you're going to do, let me erase those circles, is look at the exponent originally of the dividend. So it was a 2. Now I'm going to subtract 1, and I put that on my first term. And then I go down from there. So my next term would have to get a 0, which actually can just, all of this can just go away, because I know that anything to the 0 is 1. And then my 13 is going to be my remainder. So my answer, my quotient, is actually 2x to the first, or you can leave out that one, plus 3, with a remainder of 13. I'm going to do another example that's a little bit longer, so try to follow through the steps again. So here on the left I have my dividend, 4x to the third minus 2x squared plus 6x minus 10. And then on the right I have my divisor. So the first step again was to grab the number part of the divisor. So this is x plus 5. So if you remember, we changed the sign, so now I have a negative 5. Then I place my coefficients from my dividend in a line and draw a bar underneath. And I start by bringing down the 4. It's always the first step. Bring down the first one. Then I multiply these and put the answer here. So negative 5 times 4 is a negative 20. And then I add, so negative 2, that would be a negative 22. Whoops, the numbers are getting a little big, but that's okay. Now I do negative 5 times negative 22, which is a positive 110. Then add these two, plus those, so that's 116. And then yikes, a big multiplication problem here of negative 5 times 116. Feel free to use a calculator, but that's going to give me a negative 580. Add down, negative 10 minus 580 is a negative 590. Again, I'm going to put that bubble around here, basically because that reminds me that that's my remainder. So let's put, again, my coefficients down at the bottom. And then I know I have a remainder of negative 590. And I can see that my original dividend started with x to the third. So I know my quotient is going to start x squared. So I took that 3 and I subtracted 1 and got x squared. So then I have minus 22. The next one will just be x, or x to the first. And then my last coefficient here is actually not going to get an x. It would have x to the 0, but that's just 1. And then I do have this remainder of negative 590. Please don't let big remainders scare you. I know in regular division you generally don't want big remainders because it means you made a mistake. Here, the only time you've made a mistake is if you have an x in the remainder. As long as it's just an integer, you are all set. All right, Now for homework, I would like you guys to try 2 problems on your own. So in the first one, we have 5x to the third minus 2x squared plus 4x minus 10 divided by x minus 3. And then in the second one, we have 3x squared plus 10x minus 11 divided by x plus 4. Good luck. Feel free to email me with any questions.